This is section 3.4, exponential and logarithmic equations. So we're going to be solving equations that involve these two functions. And because exponentials and logarithms are inverses of each other, we will often use a logarithm to solve an exponential equation and vice versa. So we're going to start off with exponential equations. And the only thing that is required is that we have some sort of exponential in there. And depending on the format we are given the equation in, we have a couple of different methods to get it solved. Now, one of the things that we end up using a lot, both on exponential and in logarithmic equations, is the fact that they are one-to-one. And this property, these one-to-one properties say that if I have an exponential equal to another exponential, and they have the same base, then I can rewrite the equation by setting the two exponents equal to each other. So if I have an exponential with the same base, I can set the two exponents equal to each other. And it also works the other way. If I have two things equal to each other, I can make these both exponents on the same base. The same type of thing happens here. If you have two logarithms equal to each other and they have the same base, then their arguments are equal. And also, if I have two things that are equal, I can take a log of the same side of both sides as long as they have the same base. Okay. So the first type of exponential equation we want to solve is something where we can rewrite the exponentials so that they all have the same base. Okay. So right here, simply, 3 to the x power is equal to 243. What we want to try to do is to rewrite these so that they have the same base. Now, 3 is a prime number, so that's as good as that one's going to get. So I'm hoping that 243 can be written as a power of 3 so that they will have the same base. Now, either you can go through the prime factorization by hand. This particular calculator will do a prime factorization for you. To the best of my knowledge, the graphing calculators will not. On this calculator here, if you want to get the prime factorization, you type in the number you want a prime factorization of, so 243. Then you're going to hit the math menu, and it is number 4 down here. And you'll do that, and it will tell you that that is 3 to the 5th power. So I can rewrite this as 3 to the x is equal to 3 to the 5th power. And now, using this property right here where they have the same base, I can set the two exponents equal to each other. And here I get x equal to 5. Now, often we're going to have another small equation to solve right here, but usually it's not too difficult. This is the main step that's new. So your answer here is 5. And you should be able to type this into your calculator and double check. 3 to the 5th power is 243. So we're good. Okay, so let's do 8 to the x is equal to 4. Now, neither of these is prime, so I can write them as some other prime factorization. 8 is not a power of 4, 4 is not a power of 8, but they are both powers of 2. If I rewrite 8 as a power of 2, that's 2 cubed, so I have 2 cubed to the x is equal to 4, I rewrite as 2 squared. Now we have an exponent property that says if you have a power raised to a power, you multiply those exponents. So this is the same as 2 to the 3x is equal to 2 squared. And now, since I have exponential equation with the same base on each side, I can set their exponents equal to each other to get 3x is equal to 2. And now divide both sides by 3. And you get x is equal to 2/3. So let's punch this into the calculator to check. 2 raised to the 2/3 power does give me 4. So this is correct. So your answer here is 2/3. Okay, so what do we do if we cannot easily or at all rewrite the equation in terms of the same base? Okay, so that's going to happen sometimes. And in that case, what we do is we use part 2 of the one-to-one property in reverse. So we're going to start off with something like this with two things that are equal, and then we're going to take the log of both sides using the same base. Now, most of the time we want to use natural log or common log, and in the homework they almost always want you to use natural log. Okay, so let's look at our steps here. The first thing we want to do when we have a problem that we need to solve where we don't have the same base is to isolate the exponential expression on one side of the equation. So if you look at this first example problem, this is my exponential part, but I've got this times 7 on it, so I'm going to need to get rid of this times 7 before I can solve anything else. Okay? Then we're going to take the common or natural logarithm of both sides, and then we'll be able to use the power rule and solve. So let's just start off right here. I need this term by itself, so I'm going to divide both sides by 7, and I get 3 to the x plus 1 power is equal to 11 over 7. You do not want to use a decimal approximation until the very end of any of these problems. Okay? So what do I have right now? I have two things that are equal to each other. I have the u equal v part. Now I want to take a log of both sides, and like I said, they generally want you to use natural log. So if I take natural log of both sides, ln 3 to the x plus 1 is equal to natural log of 11 over 7. Okay. Now we have this property right here that says if you have a logarithm of something to a power, you can take that power and move it down into the front. So what I'm going to do here is this is my exponent, and I'm going to move it into the front of this. So I have this, okay? Now, since I now have my variable out of the exponent, which is good, natural log of 3 is just a number. Well, we don't want to write it down because it's a big old decimal, so we leave it in this. This is the easiest form to deal with, but it is just a number. And if you ask yourself, what would I do if it were just a 3? You would distribute here. That's what you're going to do here. If I distribute the natural log of 3, I get x times natural log of 3 plus natural log of 3 is equal to natural log of 11 over 7. Now we want to get this x by itself, and this is just a number, so I'm going to subtract it from both sides. Okay. Now to get this x by itself, I'm going to divide both sides by natural log of 3. Okay, and that's my x value. Now, on the homework, they are going to ask you to do two things. First, give the exact answer using natural logs, and then to give a decimal approximation, usually to 3 decimal places, but not always. You're going to have to pay attention to the directions there. Now, the one thing I do have to warn you about the homework, and I really hate this, and if I could avoid it, I would. This is the format they will want your answer in. Now, we have logarithmic properties that would allow us to simplify this sum. Numerically, this is the same as natural log of 11 over 7 divided by natural log of 3 minus 1, because if I split this up into two fractions, I would have natural log of 3 over natural log of 3, which is 1. I could also have simplified this to natural log of 11 over 21 divided by natural log of 3. That works too, because I could combine these and divide 11 over 7 by 3, and I'd get 11 over 21. Now the thing is, the computer, it wants this ugly answer. It counts it wrong if you simplify it. And I really hate that, so try not to get too frustrated about that. Look at their answer, see how they want it, and try to replicate that the next time. If it comes down to it, I can go in and grade these manually. But let's take this and plug it into our calculator to get a decimal approximation. You want to be really careful about parenthesis usage and everything else. So I'm going to start a fraction and do natural log of 11 over 7, close parentheses, minus natural log of 3, close parentheses, over natural log of 3. And I get approximately negative 0.58. Like I said, I usually want 3 decimal places, so negative 0.589. Now, if you want to check this, you could check it with the decimal approximation. You plug it in here, and once you did all the arithmetic, you'll end up with something really close to 11. Not 11 exactly, because that's an approximation. Or if you want to learn how to use the memory on your calculators, this is as exact as this calculator can calculate. And I'm going to store it, STO, store. I'm taking that last answer and I'm storing it into, here's your variable, X. So that now, every time I just hit X, that same number is going to come up. Sorry about that. Okay? Now, if I just plug this in here, exactly like this, 7 times 3 raised to the X plus 1 power, I get 11, so my answer is correct.